Hi dear students, in this video we are going to study about the volume of the prisms and cylinders here. Firstly, the prism is a tridimensional solid, as you see here, which the cross sections are repeating here. That's also important. What is cross section? Is the same along the whole length of the prism. So this triangle here, it is called cross section because when you move a ball to upper side, as you see here, it's repeating also. That's why they are showing like this. Or here I prepared this one for you, and as you see, this is square prism, and here when you take this one and the copy of this one, as you see here, it's repeating to this direction, especially this corner points. They are important, ladies and gentlemen. As you see, it is moving along this one, and here when I move here also, you are going to see that maybe this seems bigger and this seems smaller, but actually they are same. And as you see, when I put them here, when I put this one here, it's intersect with the all corner points with the all lengths here also. And I'm moving here again, you are going to see the same thing. You see it's going to be again connected to the, and that's why this part, it is called the cross section of the solid. This is the cross section of the solid, okay, which repeats. So with respect to the cross section, it is getting named the prism. The cuboid, it is rectangular prism, which means the rectangle is repeating here. In the cylinder, it's repeating. In the hexagonal prism, and in the cylinder, circle is repeating. In the hexagonal prism, hexagon is repeating. So with respect to that one, we are finding the volume. We try to show here like this. This is cylinder, you know, and there are layers here, and except that infinitely many layers there are. So for finding the length of this one, you should use for finding the volume of this one, you should use the length here. Okay, this is the length, and you are going to use at the same time the area of the cross section. So the area of the cross section, it is here in this figure, it is circle. Let's say this is equal to 3 units. So the area of this one, it's going to be equal to area of the cross section, which is equal to pi times r squared times the length. It is, let's show with height, or L it can be also, and let's say the height, it is 12 centimeter. So the answer, it's going to be pi times 3 squared times 12, it's going to be, and the answer, it's going to be 3 squared 9 times 12, it's equal to 108 pi is the answer of this question. It's going to be, again, I'm repeating here the main logic here. Infinitely many layers, when they come up together, up and up, then it makes one solid. And if you want to find the area also, it's related, because areas put over and over again. That's why we are going to use the area of cross section times length formula for the volume. Okay, here there are some solids. We are going to find the volume of them. Here, volume of the prism, the cross-sectional area, as you see. First, we are going to calculate the cross-sectional. We are going to find the cross-sectional area. This is the cross-sectional area, and that's why the area of the triangle times height, it's going to give us the volume. This height is equal to 12, or length it will be, I'm going to use height because generally in books they are using that formula. Area of the triangle, you know, this is a right triangle. Area of the right triangle, it is 9 times 8 divided by 2, and the height, it is given 12 here. So it's going to be equal to 9 times 8 times 6, which is equal to 9 times 8, it's equal to 72. 72 times 6, 432 it's going to be, so the unit is 432 centimeter cube it's going to be. This is the volume of the solid. Here we are going to find the volume of the cylinder. That's going to be 10 centimeter. Here the radius is, this is the r. You remember the formula for the cylinder, it's going to be base times height, which is equal to volume, and that's equal to pi times r square times h it's going to be, which is equal to pi times 10 square times 7, this is h, it looks like 4, okay, 7, which is equal to 700 pi going to be. Okay, here we have more exercises and we can solve one of them. Then we are going to solve these questions in the lesson. I want to solve this one, this figure a bit different than the others, or this one we can solve this one in the class. So here I need to find the cross-sectional area for the D I'm talking. Here there is a figure like this. First, this is the cross-sectional area because this repeats. So to find the cross-sectional area, this is the cross-section here, and the lengths are 8 and 8 up here, and it says that here also 3, this is 3, so this is going to be 5, and here 4, so if this length is 4, this is also 4, it's going to be. So for finding the area of this cross section, I'm going to divide into two rectangle. One of them, it's going to be 3 times 7, which is equal to 3 times 4, 3 times 4. The other one, it's going to be equal to 4 times 8. This is the second triangle, 8 times 4. So the area of the cross section CS, I'm going to use area of the cross section is equal to 12 plus 4 times 8, it's equal to 32. Area of the cross section, it's going to be equal to 44, area of the cross section. Then we are going to find the volume. Volume is going to be equal to area of cross section times height. Here height is equal to 10. So area of the cross section we found 44 times 10 it's going to be, which is equal to 440. Actually all the units are given in centimeters, so it's going to be equal to centimeter cube. So the volume of the cross section, the volume of the solid is equal to 440 centimeter cube going to be.